Hello guys, welcome to another new live stream. Today we are gonna review Leetcode weekly contest 435. So guys, in the chat, how many of you gave today's contest? Anyone in the chat who gave today's contest? Anyone who gave the contest, guys? Yes, did anyone give today's contest? Okay, so we'll begin our today's first question of the contest. The first question is, just give me a second, guys. So guys, we'll go for the first question. Our first question, which is maximum difference between even and odd frequency 1. So you are given a string S consisting of lowercase English letters. Your task is to find the maximum difference between the frequency of two characters in the string such that one of the characters has an even frequency in the string The other character has an odd frequency in the string. Return the maximum difference calculated as the frequency of character with an odd frequency minus the frequency of character with an even frequency. We look into the example. S is equal to AAA, AA, BBC. Output is 3. The character A has odd frequency of 5 and B has even frequency of 2. So the maximum difference here is gonna be 3, which is 5 minus 2, which is 3. And the next one, AB, CA, BC, AB. Here the output is gonna be 1 because A has odd frequency of 3 and C has an even frequency of 2. We look into the constraints. Length of S is greater than or equal to 3 and lesser than or equal to 100. S consists of only lowercase. S consists of at least one character with odd frequency and one character with even frequency. So there is no condition with 0 odd or 0 even. It's given clearly that it contains one odd and one even at least. So now, what is gonna be our intuition to solve this question? We'll go to our writing skill. What is going to be our intuition to solve this question? The intuition to solve today's problem, the first question will be, uh, what we have to do here is one character frequency is odd and the another one is even. Now, how we have to achieve this? We have to identify the maximum character with maximum odd frequency and minimum even frequency. And then we have to compute the differences. Simply, what is the first step? Max odd frequency minimum even frequency, and third, difference between these two. These are the three things we have to do in this question. So what is the approach we are gonna use to solve this question? What we are gonna use to solve this question? What is the approach we are gonna use? So the first thing is gonna be count the character frequencies. Count character frequencies. We'll use Python's counter inbuilt from collections module, which is inbuilt in the collections module in Python for this. And in our second step, what is our second step? We'll track max or and minimum even. frequencies. How we are gonna do this? We'll iterate over the frequency values, which will be getting from the counter, and then if frequency is at, we'll update it to max odd, which will store the highest odd frequency, and if it is even, we'll update it to minimum even to store smallest even frequency. Now, a final step, third one, difference. Finally, we are gonna find the difference. How we are gonna find this difference? Return max odd minus min even. I'll keep it in brackets to highlight this. This is what we are gonna use to get the difference here. I guess the approach is clear for everyone. We'll go to the code now. Here is the code. The name of the class which is given already, solution, and the function name max difference which is also given. Now, what we'll do, we'll add the commands for this one. Count is the counter. Max odd and min odd. This is, we all know that. And this is for C in count dot values, iterate. Here we are iterating all character frequencies. And now, if it is divisible by 2, minimum even, and if not, maximum odd. So this is what is a simple logic to update the values. This is for even, this is for odd, and here we have made result is equal to, this is what I said, max odd minus minimum even. This is what I was telling about earlier. And then finally we are gonna return the result. This will be the difference actually. Difference is nothing but our result, final result. We are gonna run the code and see if it works. Yeah, this is gonna work. And this is gonna work for the given test cases. Now we'll submit this and see if this works for even the hidden test cases. Here we submit it, and it works perfectly well for even the hidden test cases. Is there any doubts for anyone, guys? What is gonna be the time complexity and space complexity of this question? Time complexity and space complexity. The time complexity is gonna be O of n y, and then O of n to count the frequencies plus O of 26, which reduces to O of n plus O of 1, so O of n plus O of 1. We'll just cross this. Now, O of n plus O of 1 is equal to O of n. So our final time complexity is gonna be, so our final time complexity is gonna be O of n. Now going to our space complexity, counter uses at most how many keys? This is for space complexity. Counter, it uses 26 at a time. At most it uses 26 keys, which will lead to the which will lead us to the space usage of O of 1. Hence, the space complexity of this is gonna be O of 1. I hope everyone is clear with the first question. Now we'll go to our second question if there are no doubts. Chat, any doubts? Since there are no doubts, we are gonna go to the next question. The next question is maximum Manhattan distance after k changes. We had solved a similar question 2 or 3 contests before. Now we'll see what the question is. Maximum Manhattan distance after k changes. We are given with a string S consisting of characters N, S, E, and W, where S of I indicates movements in an infinite grid. N means move north by 1 unit, S means move south by 1 unit, E means move east by 1 unit, and W means move west by 1 unit. Initially, you are at the origin 0, 0. You can change at most k characters to any of the 4 directions. Find the maximum Manhattan distance from the origin that can be achieved at any time while performing the movements in order. Manhattan distance between two cells xi, yi and xj, yj is equal to xi mod of xi minus xj plus yi minus yj. So we'll go to the example. S is given as NWSE and K is equal to 1. So what is the position here? 0, 1. Position of W is -1, 1. Position of N is -1, 2. And position of E is 0, 2. Now, if we change S to N in this string, it is gonna become NWNE, and the maximum distance is gonna be 3. So the output is 3. I guess this question is clear. We'll go to our writing page. There are four directions: north, south, east, and west. So now N means one unit towards north, E means one unit towards east, S means one unit towards south, and W means one unit towards west. And they will be giving us the K values. What we have to find is max distance. Max max Manhattan distance, which is given by mod of mod of xi minus yi plus mod of xj minus yj. Am I correct? Let me just check. Oh, no, I'm sorry. Manhattan distance is given by xi minus xj minus yi minus yj. This is plus here. So yeah, this is gonna be the maximum Manhattan distance formula. Now what we are gonna do, what is gonna be our intuition? What is gonna be our intuition? What is gonna be our intuition, guys? I already explained this. Now, how is Manhattan distance calculated? Uh, Simple. N L draw this again. North, south, east. We shall write them here. Here it is. Okay, draw the coordinates here. This is our y-axis. This is our x-axis. And this is our origin. O. Now, if Manhattan distance, if it moves one towards north, we'll write here north, south, east, west. What we'll write here? If it moves one north, it's gonna move one north, means this is north. I'll draw that here. North, east, west, south. So one north, one south, one east, and one west will get. So now if it moves one to north, it's gonna move here plus one along y-axis. If it's gonna move to the east, then it's gonna be plus one on the x-axis. Then if it's gonna move to the south, it's gonna be minus one on the y-axis. And similarly, if it's gonna move to the west, it's gonna be minus one all along the x-axis. So this is how our Manhattan distance is given, like calculated. Now, one major thing which we want to consider here are if n minus s or s minus, okay, fine, n minus s or east minus west, if these two cancel out, which means if they are equal to 0, then we are gonna cancel that and consider the distance as 0. For example, if north is minus 1, south is 1. If north is plus 1 and south is minus 1, this is gonna lead us to north and east and west. So this is gonna lead us to 0, which is cancelling each other. Now, the next most important thing here, which we are gonna observe is we have to maximize the distance. For this, what we should do? We have to reduce cancellations by modifying atmos k modifications. And a final important thing is gonna be if we change s to n, this implies that there is plus one towards north. So this is a very important thing. Changing moment means we are reducing the opposite pairs. For example, if it's plus one towards east, it's also this implies that it's minus one towards west. Now we'll go to the approach. Anyone in the chat, what is the approach we can use to solve this question? What is the approach we are gonna use to solve this question? Anyone in the chat, guys? What is the approach? The first major step in the approach is gonna be counting the frequency of each moment. Count frequency of of each moment. Now, what is the second thing? How are we gonna do the first thing? Count the frequency. We are gonna maintain a frequency dictionary frequency with in which the count occurrences will be N, S, East, and E and W, representing the four directions. Now, the second most important thing we are gonna do is calculate calculate number of opposing directions. How are we gonna do it? We are gonna pair north and south and east and west and cancel each other. Now, we'll finally calculate after this. Finally, we'll calculate Manhattan distance. So finally, we'll calculate our Manhattan distance. And one more thing is, within this calculating Manhattan distance point, first thing is, which we have to keep in mind is, we have to k values, modify k values to get the maximum distance. And for this, how we are gonna do is, we can convert k moments to reduce opposing pairs. Opposing pairs. Opposing pairs. And next, the first point, and the second point is gonna be again a very important. Every correct removal is equal to plus 2. And the third major important point is gonna be we have to max increase. This is our third thing. And finally, we are gonna keep a track and update this Manhattan distance. Now, track and update Manhattan distance. This is a final step. Whenever we get a value, for example, the first value I'm gonna get is 3, and the next 3 will be stored in Manhattan. Now, if I get a value 5, this 3 will cancel and this 5 will be stored. Next, if I get a value 7, this 5 will be cancelled and this 7 is stored. And next, if I get a value of 9, then the 7 is cancelled and this 9 is shifted. And if this is the highest, this is gonna be our output, which will be 9. This is just an example I gave. Now, we'll go to the code. Here is our code. This is our dictionary. This is our dictionary. This is all initializing. For C, for frequency in each direction. Frequency in each direction. This is basically cancelling movements. And the next one, initial Manhattan distance. Initial Manhattan distance. And this is gonna be a Manhattan distance with K modifications. MH dist with K modifications. And now what we are gonna do? Updating. and then we'll return the result. Now we are gonna run this code. It's gonna run properly in the given test cases, and I will submit this one. And it is accepted. So now, what is gonna be its time complexity and space complexity? Time complexity, very simple. O of n, since we are gonna iterate over s once to compute frequency. Now, what about the space complexity? Space complexity is gonna be O of 1 because it's either north or west or south or east, which leads it to O of 1. So this is all about our second question. Anyone in the chat, any doubts? Any doubts, guys, in the chat? Any questions, guys, in the chat? Okay, since there are no questions, we are gonna move to our next question. Minimum increments for of my target multiples in an array. You are given with two arrays, nums and target. In a single operation, you may increment any element of nums by 1. Return the minimum number of operations required so that the element in target has at least one multiple in nums. For example, nums is 1, 2, 3, target is 4. Output is 1. If we increment 3 with 1, it is going to give 4, which implies that 4 is a multiple of itself. Now, we see the constraints. Constraints are num's length is greater than 1 and lesser than 5 into 10 power 4. Target dot length is greater than 1 and lesser than 4. Greater than or equal to 1 and greater than smaller than or equal to 4. Target length is always smaller than or equal to nums dot length. Nums of I and target of I are greater than or equal to 1 and smaller than or equal to 10 power 4. So now this is our question. What is the intuition we are going to use to solve this question? This is what is that? We'll go to the writing page now. Question number 3. Third question. So the third question now. What is the intuition? Intuition. What is gonna be our intuition, guys? Our intuition is gonna be to ensure that each element, each element in target, there is at least one multiple. Here, what is this? We need to have target I. There's a thing called target I. There's an array. So what we'll do with this is we'll try to find our LCM here, least common multiples of subsets of targets. LCM of what? Subset of target. So now what we are gonna do? We'll go to the approach. So what is gonna be the approach, guys? This uses two very frequently used techniques in data structures and algorithms to solve. First thing, recursion, and the second thing is DP, recursive function, recursive function with recursive DP function with bit masking. So our first step is gonna be first step in the approach is gonna be recursive DP with bit masking. What we'll do here is first one, we'll use a recursive function I comma m, I comma m that will process nums from index I, process nums from I, index I. Now, in the second thing, for this we have to maintain the bit masking. For this process, we'll maintain bit mask by keeping the track bit mask m. Now what we are going to do is, and the second thing, There's a base case where I is equal to n already. It will check if all elements in target are covered. That is, this checks the condition m is equal to 0. We have to check this, and if this condition works, if this works, if yes, if yes, return 0, else return, what should we return, guys? Infinity, INF, which is invalid case. Now we'll go to the second step. First step is bit masking with DP. The second step now. The second step is two choices at each step. For this, what we are gonna do is we'll skip we'll skip nums of I to function I plus 1 comma m. It means that we are moving forward without we won't be modifying. No modify. No modifications here. And in this is the first point. What is the second point here? The second point is modify nums. Now we have to modify nums. How we are gonna modify nums? We'll loop will loop over all subsets for all subsets, and next modify nums I to some subsets LCM. We will use a formula to compute the required increment R is equal to CANJ minus nums of I divided by increment R. Oh shit. Nums of I divided by can, and then this whole thing is gonna be divisible by Can. How much to add? So now we'll call the recursive function recursive function fn I plus 1 comma mn and update answer. And now what we are gonna do finally, we are gonna integrate DP with memoization to reduce data redundancy basically, so that we can store the previous values and use them next time. The third and the final step is memoization. Memoization. Here, this recursive function fn of I plus 1 comma m is cache. How will cache this? We'll use activate cache to cache this to avoid redundant computations, as I said. Now we'll go to the code here. Here comes a very simple code. Given class name, class solution, given function name, and then this is cache, which is a memoization, which is for memoization. Then this is the recursive function. Recursive function. And next, the first if case. This is base case. This is to skip the first one. Now for in range 1 lesser than t, the CAND is variable to store LCM. Now final calculation. This is to compute the LCM, and finally this we are calling the recursive function. We'll start the recursion with all targets, with all the required targets. Now we are gonna run this code. This works for the sample cases, and now we are gonna submit this and check if it works for all the cases. and the code works perfectly well for all the given test cases. Now what we are gonna do is, if anyone, what is the time complexity of this? What is the final space and time complexity of this? Now we'll see what is the time complexity. First one, loop over nums. This will lead to time complexity of O of n. Next, subset iteration. This is gonna lead to a time complexity of O of 2 raised to t. In the third step, LCM is gonna lead us to O of t. So with these three, what will be our final time complexity? We know the value of t here, it is 4. So our equation is gonna be O of m into 2 raised to t, because this other one is which is O of 4, it will reduce to O of 1 and we'll simply ignore this, considering O of m into 2 pi t, which will turn into O of n into 16, which will conclude to O of n. So the final time complexity is gonna be O of n, going to the space complexity. Memoization table. I'll just write it as memo table. Okay. The memoization table is gonna take a time or a space of O of m into 2 raised to t, which will lead to O of n into 16, which is nothing but O of n. Now, what is the another thing? Recursive stack. Stack. Recursive stack. Recursive stack is also of O of n, which leads to the final space complexity O of n. Guys, anyone has any doubts in this question? Any doubts? Anyone? If you have any doubts, you can please ask in the comment section in the chat. Okay, I guess there are no doubts for anyone. We are gonna go to our final question of the day, which is maximum difference between even and odd frequency 2. Similar to our second question of the maximum difference between even and odd frequency 2. You are given with a string s and integer k. Your task is to find the maximum difference between the frequency of two characters, frequency A minus frequency B, in a substring subs of S such that subs has at least size k. A character A has odd frequency in subs, character B has even frequency in subs. Return the maximum difference. Note that sub contains more than two distinct characters. And we all know what a substring means. It's a contiguous a sequence of characters within a string. We'll go for the example. S is equal to 1, 2, 2, 3, 3. K is equal to 4. Our output is -1 because for substring 1, for the substring 1, 2, 2, 3, 3, the frequency of 1 is 1 and frequency of 3 is 2. So the difference is gonna be 1 minus 2, which is equal to -1. Now we'll see the constraints. Length of S is lesser than 3 into 10 power 4 and greater than 3. S consists of digits 0 to 4, and also the input is generated that at least one substring has a character with even frequency and a character with odd frequency. And the length of K will be greater than 1, greater than or equal to 1 and lesser than or equal to S dot length. So now we are gonna go for the intuition for this question. Now guys, what is the intuition? Similar to our second question, I think second or the first question, I'm not sure. Yeah, similar to first question, a little similar to first question. Intuition is the question number 4. Intuition. What is the intuition? Our intuition is gonna be there is K which has odd and even frequencies, and here two major points. Substrings must be contiguous. So because of this, brute force approach will be too long. Brute force is gonna be very long. Now what is the second most important point here? The second most important point is instead of this we are gonna track the frequencies differently. Track frequency differences. Now how we are gonna do this? We'll go to the approach. Anyone in the chat, guys, what is the approach we are gonna use to solve this question? The approach. First one. Pairwise characters comparison. Pairwise characters comparison. The second. For this, we are gonna iterate through all pairs of distinct characters. Distinct characters in Distinct characters A, comma B in S or A in S. Now, then max frequency. Now, the second point, as I said, brute force fields will track frequency efficiently, frequency differences efficiently. How we are gonna do this? We'll use our very commonly used technique, prefix sum calculation. Prefix sums CA CA and CB. We'll use CA and CB. And then what we are gonna do is, along with this, we are gonna use a hash map. We're gonna use a hash map to store frequency. To store frequency. Now our third step, very important step. Here we are gonna use one of the most commonly used approach to solve these kinds of questions. Sliding window. So how we are gonna use the sliding window here? We'll maintain valid index II, valid index II. Ensure that length is greater than or equal to k. Then we'll update difference is equal to CA of -1 minus CB of -1 at every step. Now third, we'll utilize stored values. Use stored values. For step 2. For step 2. Calculating the maximum difference efficiently. Now our fourth and the final step is final computation. Here what we are gonna do is we'll iterate through all valid pairs A, comma B, and we'll determine max possible differences. Now we'll go to the code. It's a simple code again. Class solution given, function max difference given. We'll use another function fn of a comma b. max frequency. To compute the max frequency, this is all declaration of a dictionary, array, etc. We'll use this, we'll go for this I-comma. This is to extend prefix sum array. This is left pointer for sliding window. Double I equal to 0. This is the left pointer for sliding window. And negative infinity as answered initializing. In the first if case, if ch is equal to a, increment count to a, and this is a, if ch equal to b, increment count to b. Now within this there is one more loop, which is while loop, window size. The sliding window size greater than or equal to k. The kk is frequency parity at ii. The next one CII minus CABB. CBII frequency difference. This is frequency difference. And now scene will store the minimum difference, mean difference. And finally, this if else condition. Update the global max. Update the global max. And now finally, this is for iterating through all distinct pairs of character. And this is a final updating. This is a global max. Sorry guys. Update a global max value. And finally return our final answer. Return the final answer. So we are gonna run this one and see if it runs. It's accepted in the given test cases. Now we are gonna submit this and see if it works. Works perfectly well for all the test cases and it's accepted. So now, what is gonna be the time complexity or space complexity of this? The last topic for today, space complexity and time complexity. For the outer loop, it is gonna be O of phi square because it's of range 0 to 4. Now inner function, it's gonna be O of n sliding window, which is also gonna be for O of n. So the total time complexity of this is gonna be O of 25 into n, which leads to O of n. So the time complexity of O of n, since 25 is a constant, now what is the space complexity, guys? Space complexity. Prefix sum arrays. Prefix sum arrays. We all know how much it will take. CA, comma CB. It's gonna take O of n. Second thing, hash map. Hash map, it's also gonna take O of n, leading to the final time complexity of O of n. Sorry, leading to the final space complexity of O of n. With this, we are gonna end this. Now, guys, if any of you has any doubts, please ask in the comment section so that I can clear your doubts. If there are no doubts, we are gonna end today's live stream with this. So I guess that's all for today, guys. There are no doubts in the comment section, so we are gonna end today's live stream with this. Thank you guys for everyone who joined for the stream. Thank you all. We'll see you the next week, next Sunday, with the next weekly contest 4:36. Until then, have a good time. Thank you for tuning in. Bye bye. Have a nice day, guys.